Hi Aya. This is a very budget video. I'm literally just holding my phone, but it's easier, I think, the easiest way to explain. So, first question then, you've got these structures, and question A asks, oh, blimey heck, I'm poorly prepared here, hang on. Okay, 2 of the molecular ions fragmented to form an ion with 130 MZ value 133 by losing a radical. So that means that if it tells us in the question that the peak at MZ, M over Z, by the way, is basically the mass number divided by the charge, and we assume that the charge on all of the ions is 1+. Now, you can get ions with a higher charge than that, in which case it becomes a little bit more complicated, but for the A-level spec, you assume the charge is always 1+, which basically means the MZ value is just equal to the mass number of, or the MR, basically the AR or the MR, depending on whether it's an atom or a molecule, okay? Obviously, if you're dividing the mass number by more than 1, then it wouldn't be the same, but for argument's sake, it is. It's just the same thing. Anyway, so that's the MZ value. So basically the mass number, if you like, of those molecular ions is 134, and if they fragment to then leave a value of 133, then obviously it means they've lost something with an MR of 1, which has to be hydrogen. Okay, right. Next question is B. Okay, so they are, what was it? So 2 of the molecular ions fragment to form an ion with an MZ value, or an MR basically, of 119, and you need to identify the radicals the radical that was lost. So after the radical is lost, the structures are left with an MR of 119. So 134 minus 119 equals 15. Okay, so we know that whatever the radical that was lost, that it has an MR of 15. Now, you could possibly just look at that and sort of fairly quickly think, well, it's probably going to be a methyl group because 12 plus 3 is 15. But if it wasn't such a kind of simple number, you can say 15 divided by 12, which is the AR of carbon, and that gives you a value of 1.3. That means we're going to have 1 carbon, so it's going to be C, and then whatever's left over, so obviously that has a value of 12, we've got a total of 15, so 15 minus 12 equals 3, which means we've got 3 hydrogens. Okay, so it's going to be CH3, and it's a radical, so I'm going to put my dot in, although according to the mark scheme you don't have to. Okay, then question C is a similar thing. Just get that up, sorry. So this time you're told that you're left with structures that have an MZ value or an MR of 105 because they've lost radicals with a value of 29. So you're asked to name 2 possible radicals. I'm going to start by finding an alkyl radical that could have been lost by saying 29 divided by 12, the AR of carbon, which is 2.4. That tells me that it's going to have 2 carbons in it. And then I can say that 12 times 2 is 24, and if it's got a total MR of 29 and the carbons are bringing 24 of that, then it must mean that we've got 5 hydrogens left. And again, that's a radical. I'm going to put that dot in. And then in terms of what your other one could be, so that's radical 1. Radical 2, if we have a look at our structures, you can't start kind of lopping off stuff in the middle of a structure. So you can take off that, you could take off that, we can get rid of that, or we could get rid of all of that, or we could just get rid of that. Get rid of that. Again, that or all of that, or that, or that. Okay. And if we just kind of look here and do a quick bit of maths, we can see 12 plus 16 is 28, plus 1 is 29. So our second possible radical is CHO. Okay. I'm not sure if you wanted me to do D or not. Yeah. Okay. Email me. Bye.